State variable analysis. What is a state variable? The state or the status of the variable system is the minimum set of the variable known as the state variable, such that the knowledge of this variable at time t equal to t0 together to the knowledge of the input u of t completely determine the behavior of the system for any time t is greater than t0. So in a mechanical system, x of t, v of t, f of t, and this is the zero friction and state variable. X of t is x1t is assume x of t, x2t assume v of t. So input variable u of t is equal to f of t, output variable y of t is equal to x of t, f of t is the m into dvt by dt, vt is dxt by dt, x of t equal to x of t0 plus integration from t0 to t vt dt, and vt is equal to v t0 plus 1 by m integration from t0 to t f of t dt, where f of t is m d square x by dt square. State model is the function of input output state variable is the state equations. For the system is not LTI, then the state model is used. The state equation S dash t is a function of xt and ut. Output equation yt is the function of xt, or yt is the function of xt ut. Here fs is m into s square after Laplace converting by using a Laplace. Fs is equal to m s square xs, xs by fs equal to 1 by ms square, xs equal to 1 by ms into fs. So if ft is given 10 Newton, m 10 kg, then put the value, we get 1 by 10 s square into 10 by s, and xt after inverse Laplace we get xt equal to t square by 2. Now general state model. The general state model x dash equal to ax plus bu is the state equation, and y equal to cx plus du is the output equation. This whole thing is the state model. X is the state vector, a is the system matrix, b is the input matrix, and u is the input vector, c is the output matrix, d is the transmission matrix. So if n state, n input and p output, then the equation x n x1 a n into n, x n into m plus b n into m, u m into 1, y px1 equal to c p1 p into n, x n into 1 d plus d p into m into u m into 1. Advantage: the application for MIMO system, it gives complete information including the internal state of the system at the given point of time. Application for the linear time varying and linear time invariant system. It is also used to determine the controllability as well as the observability of the system. It take the initial condition into account. Disadvantage: involves the mathematical calculation in a matrix algebra. Pole 0 and pole n 0 cannot be determined directly. Difference between transfer function and the state model. In transfer model is not applicable. In the transfer model is applicable only for LTI system, whereas the state model is applicable for any system. State model system can be analyzed only in time domain. Zero input response can be obtained by the state model. Now we know about the controllability and the observability. So what is a controllability? System is said to be controllable if it possible to transfer the system from one state to the another state by using the input vector over a specified period of time. Kalman test on of observability, QC equal to b ab a square b dot 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 a n minus 1 into b is uncontrollable. It is uncontrollable if rank of the matrix QC is less than that of the order of the system. Number of the uncontrollable systems are equal to n minus r. Number of a controllable state are equal to r. Rank. Observability. The system is said to be observable if it is possible to determine the output of a system simply by knowing the internal state of the system at any given point of time. So Kalman test of observability Q naught is equal to CT AT CT A का पावर T का होल स्क्वायर C का पावर T डॉट 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 A का पावर T n minus 1 C का पावर T. The number of the unobservable state are equal to n minus r. Condition for the state observability Q naught is not equal to 0.